Insert funny, creative, goofy YouTube slogan here. Here we go. Let's talk about law of cosines today. All right. So if you think back to what we did in the last video with law of sines, we were working with problems where we always had one side and then the opposite angle. Right. We were always working with pairs like that where we had the opposites, right? Opposite sides and then the opposite angle. So with law of cosines, you don't have that. And that's the advantage of law of cosines, is even if you don't have one of those opposite pairs, you can still solve the rest of the triangle. Okay, so let's jump in with law of cosines. So, law of cosines, you're going to use it when you have side, 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 or side, angle, side. Okay, and there's actually three different equations here, right? You've got a squared is equal to b squared plus c squared minus 2bc times the cosine of a. And then you kind of continue that same pattern. But if you're noticing, right, like this one has a squared by itself and then b squared, but it's also cosine of b, c squared and then cosine of c. And you're multiplying, right, like here we've got a squared, b squared, c squared, and then we're subtracting 2 times those b and c, which is, not a, right? And then cosine of a, though. So it's a formula. You can use them in various different points, but essentially you're going to use it to find either this or this. Like if we're trying to find little a using law of cosines, then we're going to use this equation. If we're trying to find big A, then we're going to use this equation. Same with b, little b, right? If you want to find little b, we're going to use this one. If we're going to find big B, we're going to use this one, or the same one, sorry. Little c or big C, we're going to use that third equation. Okay, that's what ends up. That's the important part about law of cosines. That's when you use what. Okay. Let's see. Steps. Draw your triangle as accurately as possible. It does help you to do that because just better visuals and everything like that, right? Make your obtuse angle obtuse. Okay. Try to make your acute angle acute, etc. Okay, but there's two different outcomes. Side, 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 and side, angle, side. Now, let's just talk about the steps first. In side, 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 you always need to find the largest angle first. Okay, that's actually a really important step. So make sure you do that, and it's easy to forget about it. Okay, so you want to find the largest angle first using the law of cosines when you have that side, side, side. Now, I actually don't technically know. I'm going to be honest, I don't know why you have to do that, but apparently it leads to some issues. Where there's sort of two different outcomes potentially if you don't do that, I think, something like that. But, people before you have laid the groundwork, right, for law of cosines. So follow the groundwork here, but always follow that, find that largest angle first. Cool? Then you're going to find the next largest angle using law of sines, and then the smallest angle by doing the 180, right? Every triangle adds up to 180. So now, you could sit here and you could try to memorize this, but I'll tell you now, once you apply the law of cosines, the rest kind of lays out exactly kind of what we were doing before. So we end up with, I'll tell you now, once you find that largest angle, you end up with an opposite angle and side pair, which means we can now use law of sines. Okay, side, angle, side. Find the third side using the law of cosines, then sines, and then the law of sines, and then subtracting from 180, okay? You will see it kind of, the information that we get from doing law of cosines once leads to similar problems to what we were doing before, okay? Let's do it. Here's an example, okay? And really the truth is law of cosines ends up being almost the same thing over and over again. So I'm just going to do two examples. We're going to do one with side, 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 and then one with side, angle, side. So example number 1, find the measures of the angles. Here we have a side, and a side, right? So this is my side, side, side problem, okay? We want to start with, this is an important step, right? You start with finding that largest angle first. So we've got to identify which one's my largest angle. Well, this is my largest side, okay? Back in geometry, you learned that, your largest side is actually indeed across from your largest angle. So we want to start with B first, okay? So make a note, start with largest angle. Okay, and this particular one happens to be B. Okay, so let's go ahead and start with B. So I want to find B first. Here's my work. for b. We'll do that right here. All right. So here we go. We're going to find b. Now, if you remember what I had mentioned earlier, right, this is the equation I want to use, right? It's b squared equals a squared plus c squared, right? Because I'm trying to find big B, okay? I'm trying to find, yeah, big B here, okay? So since I'm trying to find B, I'm going to use this second one. I'm just going to write that equation to start off with, okay? B squared equals a squared plus c squared, okay, minus 2 times a, little c, and then times cosine of big B. Okay, keeping our eyes on this goal right here, that is what we're trying to find. Okay, so let's go ahead and begin. Okay, let's label what we do have already. Okay, and turns out, right, if that's big B, this is my little b. Okay, here's big A, that is my little a. Over here, little c. Okay, so we now have those parts. So let's go ahead and fill it in. So we've got little b, we know to be 19. So I'm going to go ahead and put 19 squared. Okay, little a, is 14 squared. Over here, plus c, that is c squared. Okay, and then I've got minus. Now I want you to notice this. Okay, this is 2 times a times c times cosine of b. So there's a lot of multiplying in there. So just be careful, right? We want to be careful with PEMDAS, right, or order of operations on these, because you don't want to forget that we're multiplying in here. So when we actually do end up trying to solve for big B, it's just something to keep in mind with the operations here. Okay, so 2, and then times little a, which is we found to be 14, and then times little c, which is 8, and then times cosine of b. We don't have b yet, right? That's what we're trying to find. So we're actually going to leave it right now as cosine of b. Okay, so let's go ahead and get some of these. All right, let's do 19 squared. 19 squared is 361, so I'm going to go ahead and do 361 equals, and I'm just going to continue to work down, right? 14 squared, that's 196. Okay, 8 squared, that is 64. Okay, and then minus 2 times 14 times 8, so 2 times 14 times 8. Again, being very careful with our order of operations here. Okay, times cosine of b. Now, remember, we are multiplying all in here, so this is like a, like we can't detach these, right? Do not fall into the mistake of doing 196 plus 64 and then subtracting here, right? These are attached. This is like, 224 times x, right? We don't detach that 224 from x, and similarly, we wouldn't detach the cosine of b yet. So yes, we can combine these two. Okay, and then eventually we'll swing those over. Okay, so anyways, we got 361, okay, and then equals 196 plus 64, that's 260. Okay, minus 224 cosine of b. Again, don't separate these. Okay, don't separate those. All right, we can get this to the other side. We'll just subtract 260 on both. So I'm going to be at 101, right? Double checking, yeah, 101, okay, equals negative 224 cosine of b. Okay, now my goal is to get cosine of b by itself. All right, well, think about what we're doing here, right? This is, right now, we've got negative 224 times cosine of b. So we're actually going to divide both sides by negative 224. So here we go. Right, cancels over here, and I've got 101 over negative 224, and then that equals cosine b. Now, how do we solve it when we're at just cosine of b? Well, this is where we're going to use our inverse cosine here. So b ends up being cosine inverse of 101 over negative 224. Can't see it because my face. But here we go. That's what we will put into the calculator. Make sure you're in degrees mode. Double check that. So you're in degrees mode. We're good on that. And I guess I can't really get this to focus, but let's get that mouse out of the way. But we're going to do second, right? Second cosine to get us that cosine inverse. And that's what we're going to put in. 101 over, negative 224. Make sure you keep that negative in there somewhere. Okay, and we're going to get about 116. So that is what we are going, oh no, I guess we'll go ahead and round it up to 117 degrees. Okay, so B is equal to 117 degrees. That's 1. Okay, so now we found big B. All right, big B. And once we find something, right, make sure to label it. 117 degrees right here. When you label it, you see the patterns a little bit easier. It makes it a little bit easier on your brain. You end up doing less work. Okay, so we now have an angle and side pair that are across from one another, right? That's what I was mentioning earlier. And so now we can actually use the law of sines. Okay, so because I have an angle and side pair directly across from one another, now we can use the law of sines. And let's go ahead and do that. Let's find, really doesn't matter which one. Okay, you can find A or C here. I'll just stick to my little notes on the side, and I'm going to go with A. All right, so I've got A, right? And let's set up our proportions. We've got little b, okay, over the sine of b, which is 117. Almost put b. That's a 1. All right, so 19 over the sine of 117, okay, that equals, well, little a, which is 14, over the sine of a. So this is one of those ones where we're trying to find the angle, okay, so just be careful. We know at some point we're going to have to use sine inverse. All right, but we're multiplying here, and then we will eventually, well, let's just cross multiply. So we got 14 times sine of 117 equals 19 times sine of a. Now, we're going to divide both sides by 19. So I end up with 14 times sine of 117, all divided by 19, equals sine of a. And then we will get a is equal to sine inverse of all that stuff. Ooh, cutting it close here. Barely able to fit it. And I'll work up, just so you're not super confused there. But we've got sine inverse of all that we put there. So 14 times sine of 117. You know me, I'm weird about my parentheses, but I'll be bold today. And just divide, and we are going to get 41 degrees there. Okay? 41 degrees. That's A. All right, so little a, that's 41 degrees. Okay? Now, for C, you could absolutely sit here and do law of sines again. I'm not going to stop you from doing that. Okay, you have free will here. But use your, in math, we're always trying to make things as easy as possible. I know it doesn't seem like it as a student, but we really are, right? We know that our triangles here have to add up to 180 degrees. So let's use that property to find C. So C is equal to 180 minus 117 minus 41, and that should get you 22. Okay, so C is 22 degrees. We found the rest of our angles when we were only given sides. There we have it. Example 2, side angle side. Okay. First, we're going to draw the picture. Okay, so we're going to make this here, that angle, 115. Okay, labeling it as A. We're going to complete the triangle. I can't claim for that to be the best looking triangle I've ever drawn. Maybe that's a little better. Okay, 115 there. All right, and you've got to be careful with how you set these up, guys. Okay, so we don't have A here or here. We have B and C, so it really doesn't matter which one, as long as A is not across, right? Or as long as these aren't across. We don't know little a yet, okay? But so that means that 15 cannot be here, 10 cannot be here, right? But you could do this and this if you want. But the second you make that 10, right? Make sure you're being organized, right? C is your 10, so here's your side. That means it's going to have to be across here, so that's big C. Here's your 15. That means this is going to have to be big B. And we don't have little a. All right. So first, we are going to find the side across from the angle. Okay, so it says on our steps here, right? The best way to do this is to find that third side using the law of cosines. Okay, so the third side, right? I have the 10, the 15. I'm missing that right there. It's A, so I'm going to use that formula for A in my law of cosines. So A squared equals B squared plus that one, the top one, right? Where A is over here and also over here. Okay? So we've got our work for that. Let's go ahead and we'll do that in light blue. Okay, so we're trying to find A, and here's our work for it. We've got A squared equals B squared plus C squared. Okay, minus 2 BC. Okay, 2 BC times cosine of. Excuse me. Here's the A, so this one matches up here. Cosine of A on that. Cool. Let's plug in everything we know. We do not know A. We're going to leave that one there. We do know B. Okay, little b. It might help to label things just in case. All right, so this is my B. This is my C. Okay, so it doesn't get confusing. We've got 15 squared plus 10 squared. Okay, minus 2 times B times C. So that's times B times C. That's 10 here. And then we've got cosine. Okay, so this one's a little bit different. We actually know what big A is on this one. So cosine of 115, right? So we can actually fill that in, right? So if you compare what we've done, this first set of just plugging things in, to what we had earlier, here it is, this line right here. Okay, so it was, once we plugged everything in, the angle was missing here. But once we plugged everything in here, it was the side that's missing here. So that's the big difference. If you ask me, these are a little bit easier, okay, because you can actually put that entire thing into the calculator if you really wanted, okay. Personally, I don't like to do that, but you could put everything into the calculator there, okay. And then you'll take the square root on both sides because that's how we're going to solve for A, all right. But again, me personally, I do not like to put everything into the calculator because I like to trust my own, yeah, I'm going to use the calculator to get some of this, right, but and I'm going to need it for cosine 115. I just don't like putting it all in at once. I think it helps us understand the processes a little bit better without just doing that. So I'll do 15 squared, okay, and then add 10 squared. You notice that I'm not putting it all into one line, right? So, and then I'll do minus, and you got to be careful here. If you do want to put this entire section of the calculator, this is where I would probably do it. But you have to be careful. This is minus all of this stuff, but you got to multiply it first. Okay, so you have to multiply it first. So make sure you put a parentheses there. All right, make sure you put a parentheses there just in case. Okay, and so you got 2 times 15 times 10, and then times cosine of 115. That closes out that parentheses, and then we've got one more. And that is going to be what A squared is equal to. Okay? So we've got A squared equals all this stuff. So how do I find A? Well, we take the square root. Okay, so I've got A. Well, let's just go ahead and do it now. All right, so the square root of that stuff. Okay, second answer, if you don't know where I got that, it's right here. You're going to click second and then answer there to get that. And what that's doing is that's putting this 451 into the square root. We will hit enter, and we're going to get 21.3. We'll round it to the nearest tenth there. So I've got A is equal to 21.3. All right, so I have my third side there. Okay, so this is 21.3. And now you should notice that I have an angle and a side combo, right? The ones right across from each other. So this is where we will come in and use law of sines, okay? So since I have that combo, I'm going to do 21.3 over the sine of 115, right? Always in here is your angles, right? Some people will flip these, okay? Be careful. Sine of 115, right? My sine, cosine, tangent inputs should always be angles. All right, so 21.3 over sine of 115 equals, and doesn't matter, okay? You can pick B or C. I'm going to pick my notes. I did C, so I'll be consistent with that. So I've got 10 on top, and then sine of C on the bottom, okay? Maybe we're okay with this, maybe we're not, but quick little step, right? C is equal to the sine inverse, right? You end up multiplying these two and then dividing by this. So it's sine of 115 times 10, but then over 21.3. Okay, maybe we're cool with that. Maybe we're not. But that is going to get you your C. Okay, we've done plenty of examples of law of sines at this point, so hopefully you kind of see where I'm getting that value. Okay, but you can do the steps. You can cross multiply and solve, and then do your inverse, and you should see where I got that. Okay, so that's what we'll put into the calculator. Sine inverse of sine of 115 times 10, but then divided by 21.3. And you're going to get 25, we'll just leave it at 25 degrees. Okay, so we've got C is equal to 25 degrees. Boom, close it. And label it. 25 degrees, right there. Could you do law of sines again? Sure. I wouldn't do that. Lots of extra work. So to find B, we know it's equal to 180 minus 25, but then minus 115. So B is going to be, let's see, minus 25 minus 115. That's going to give me 40 degrees, and we are done. That is problems involving law of cosines. So if you notice, it's not like your law of sines where you're doing like law of sines multiple times. And it's basically replacing one. Like if you remember in those law of sines problems, typically you're doing it twice. Essentially, this one is just your first step needs to use law of cosines. And then it's like a trickle-down kind of effect to find the rest. All right, so to be consistent here, we'll label it, there's 40. Okay, that is law of cosines. Insert motivational quote. Oh boy. Hope you guys have a great day. Y'all take care. Y'all are doing great. Keep it up. See you later.